Alright, so this is the simplifying square roots practice video. I'm going to do 3 square roots without a negative, and then a couple simplifying square roots that do have a negative in them. We're going to get a lot of practice here, but make sure that you understand I and how to find a simplified square root. You need to know the first 12 perfect squares. You can obviously use your calculator, but it helps you a lot if you know the first at least 12 perfect squares. So I'm going to write them here at the top of our board. I wrote that wrong. 144. I'll go up to 169. So that's 1 through 13 of perfect squares. I'm going to reference that list all the time. So when I look at 68, remember I want to start by rewriting that square root as the product of 2 other squares. My goal is to find a perfect square from this list that multiplies into 68. I want to find the biggest one. So here, I actually know that the square root of 4 times 17 equals 68. Now, I'm not going to write this in all of them, but when I start them out like this, 4 times 17, a rule about square roots is that I can simplify that. I can break the square root up over the multiplication symbol. So I can take the square root of 4 times the square root of 17. Now, the square root of 4 is 2, and the square root of 17 doesn't break down. So your final answer is 2 radical 17. Now, I'm going to show you how you can check your answer here really quick. If I go to Desmos and I type in my original problem, now it's not going to simplify square roots for me, but it'll give me a decimal. So it tells me that that decimal is 8.25 or so. Let's type in now what we got our answer to be. 2 times the square root of 17. I also got 8.25. I got the exact same answer, so I know I simplified correctly. Okay, when I go back over here, let's look at number 4. The thing about square roots is that they break up over multiplication, and I can break it up over a fraction. So I'm going to start by rewriting this as radical 20 over radical 9. Now, radical 9 is the easy part. Radical 9 is a perfect square. It's 3. So I can get rid of the denominator already. The numerator, 20, I need to break up into perfect squares. Now, 20 is 4 times 5. 4 is a perfect square. So I'm going to rewrite this as radical 4 times radical 5. That equals radical 20. Radical 4 simplifies to be 2. Radical 5 does not break down, so that stays as radical 5 all over 3. Again, I can check this answer. If I go back to Desmos, I can type here radical 20 divided by 9. And I get 1.49. In the next box, I can type, 2 square root of 5. Now arrow out. If I did a divided by 3, I again get the same answer. So I know that I simplified correctly. Last one here, 2 times radical 120. That coefficient is important. It's going to stay there. But I'm going to multiply that coefficient by the product of these square roots. Now, the biggest perfect square from my list that goes into 120 is, it turns out they were all 4 this time, but it's 4 times 30. Now, again, that coefficient of 2 stays there. It's part of the problem. Radical 4 breaks down to be 2, and radical 30 does not simplify anymore. So all you have left to do here is multiply. 2 times 2 is 4, and the radical 30 stays the same. All right, so again, you could check your work. Oops, wrong thing. I want this. So if I went here, 2 times radical 120, and then I do 4 radical 30, I get the same answer, so I know I'm correct. All right, now the next set has a negative underneath. These were the new ones for us. Remember, anytime I have a negative underneath the square root, you need to know that the square root of negative 1 equals the number I. You're always going to have an I in your answer if there's a negative under the square root. Now when I break this down, I'm going to pull out a square root of negative 1. That's the first one. And then you have to know that 12, the perfect square that goes into 12 is 4 and radical 3. Those multiply together to be negative 12. Well, the radical 3 stays the same. The square root of 4 is 2, and the square root of negative 1 we said is I. And the convention, the rule is, we typically write the I after the 2. If you wrote I2 radical 3, that is correct. It just looks a little funny. We're used to 2I radical 3. Okay. Last one here. I rewrite this. I pull out the square root of negative 1. And if you are careful, you should know that the square root of 36 is actually a perfect square. The square root of 36 is 6, and I'm going to put my I on the end. Now these can be a little bit tricky. We're going to use them the rest of the unit, but you need to make sure you can simplify them here. So try the rest of the problems, ask for help, and check your answers on the bottom of the page in the Key on Campus.